Hi there, this is LeetCode 1365. How many numbers are smaller than the current number? Given the array nums, for each nums, find out how many numbers in the array are smaller than it. That is, for each nums of I, you have to count the number of valid j's, such that j is different of I, and nums of j is less than nums of I. Return the answer in an array. Let's see example 1. So this is the result array, and for each cell here, it's the number of the count of numbers present in this array that is less than this one. And the same here, the count of numbers in the entire array that is less than this one here. Okay, so this seems to be a simple solution because we can think fast in a brute force approach. We can have two fors iterating through this array here, and for each number we can check the entire array for numbers that is less than this one, and when we find a number that is less than this one, we can increment a count variable, and when we get at the last number, we can put the count variable here in the result array. Yes, this will solve this problem, and the time complexity for this solution is big O of n squared. When we are working with array of numbers, we can always try to think how can we improve the time complexity. And here we can think and mix up two approaches. As I said, we are working with an array of numbers, and every time we are working with an array of numbers, we can ask ourselves, can I sort this array to improve the time complexity? And also, the exercise is asking us to count something. Every time we have to count something, we can think in a hash map approach, because using a hash map, we can save previous computation to use in the future. So by doing that, we can decrease the time complexity because we will decrease the computational that we have to do to solve this problem. So yes, let's do that. We will sort the array, and we also save the value and the index of this value in a hash map. Let's see how can we do that. Okay, so even if the exercise is not asking, it's always good to check if the input is valid. So if we have an input that is not valid, we can just return an empty array here. So an empty array of size 0. Okay, so now we can sort the array, but we don't want to sort the original array because we will use the original index of all the numbers in this array. So we need to copy the numbers into an auxiliary array and sort this auxiliary array. We can do this like that. So var sorted nums is equals to new array with the same length. We can also copy every number from the original array to the sorted array, and we want to copy everything. Now we can sort. We can sorted nums. Okay, like that. And as I said before, we will use a hash map to save the previous computation. And I can try to show you what I'm saying here. Imagine a hash map with the current example. So we have the array of the example 1 here, and we also have the result for this input. So imagine a sorted array of the original input. So we have 1, 2, 2, 3, and 8. So this is this array here is this one sorted. And now imagine a hash map with these values and its indexes. So for the first one, we have the number 1 index 0, number 2 index 1, and here we don't want to put the duplicates. Number 3 index 3 and number 8 index 4. With this hash map, we can assume that every time I ask how many numbers in this array are less than 3, I can just get the value of the hash map. That will be the result. So here we have the number 8. If I ask to the hash map what is the value of the index 8, the key 8 here, it's 4. So there are 4 numbers in this array that is less than 8. And I get this in constant time because we are using a hash map. So let's see how can we code this. First we need a hash map. And also we need to put values in this hash map. So we will iterate in the sorted numbers. And as I said before, we don't want to put duplicates in this hash map. So we will start checking if we already have the current key. So if this key is not present, if this key is not present, I will add it. And also its index. Yeah, that's it for the dictionary. Now we can start to think about our result. So let's create a result array with the same length of the original one. And we can just now iterate through the sorted numbers or the original array. Yes, it will be a sorted in. We will have to iterate now through the original array because let's see. We have the original array here. We want to ask to the dictionary how many numbers in the array is less than 8. So the dictionary will give us the value 4 and so on for the other numbers. Yes, so let's iterate through the original array. And to get the result, we just need to ask the dictionary. So dictionary, give me the index of this key here. Yeah, now we just need to return the result. Yes, if we don't have any typos, I think That's the solution for this exercise. The time complexity here is big O of n log n because of this line here. A good sorting algorithm will give us n log n. And even if we are iterating here through arrays, we are not doing that in a chaining way. So this is a flat way. So even if the nums gets bigger, this is not multiplied by itself. It's just an incrementation. So that's why the time complexity here is big O of n log n. So let's run to see if the code works. Type int line 19. Let me see. Okay, result of I. Try to run again. Yeah, it works for this scenario. Let's try to hit submit. Yeah, that's it, guys.